Okay. Okay. So 90 degrees, we want to convert that into radians, okay? So to go from 90 degrees to radians, we're going to multiply, right? Over here, what do? We want to multiply by pi over 180. Okay? That's what we want to do. Actually, I think it should be degrees. That's all right for now. So we have 90 degrees times pi over 180 degrees. And when you do that, the degrees are going to cancel, and you're left with 90 pi over 180. Okay? And so what is that? But 90 over 180, that's 1 over 2. So we really have pi over 2. I mean, if you happen to write out radians on an exam or something, I'm not going to take points off of that. People usually don't write radians, though. Okay, I think on the notes here, I forgot to put degrees here and here, so I will fix that later. I apologize for that. But here, it should be pi over 180 degrees. We should have 180 degrees over pi. I think I forgot to put that in. Sorry about that. But hopefully you still get the idea. For 270 degrees, same idea. You want to multiply by pi over 180 degrees. That's going from degrees to radians. I mean, you can think of it this way. The degrees are going to cancel if you do that. So you'll get 270 times pi over 180. And it is good to write that in lowest terms. It's 3 pi over 2. But again, pi you don't write the decimal form for. Okay? People just don't do that. Okay? Now let's go the other way, radians to degrees. Okay? From radians to degrees, we have 2 pi over 3 times 180 degrees over pi. And you want your answer to be in degrees. Okay? So for 2 pi over 3, I know I wrote radians here, and I said people don't usually write radians, but again, if you happen to write radians on an exam or something, I'm not going to take points off. So to multiply like this, the pi's are going to cancel, as you can see. And 180 degrees over 3 is 60 degrees. So you'll have 2 times 60 degrees, which is 120 degrees. You'll have that. Okay? That's what you'll have here. And pi over 6, same idea. Pi over 6 times 180 degrees over pi. Again, the pi's cancel. 180 degrees over 6 is 30 degrees. That's what we get here. Okay, any questions on this? Next one's I was going to let everyone try. Okay, good. Okay, we'll just do something. There we go. No. There we go. Starting crazy. Just fix this now. There we go. Now I feel better. I was afraid I forgot to do that, so I did it now. All right, so for not the next slide, but the slide after that, let me just get to that. Here, okay. So here I want everyone to try these now. Take about 4 or 5 minutes. Take about, like 2 minutes or so. You're basically going to do the same thing as you did here, as we did here. To go from degrees to radians. Okay. Actually, wait. I think I sent you the solutions by mistake. So let's just do them together. All right. We'll just do them together. Actually, my mistake. I forgot to take these off the notes I sent, but that's okay. We'll just do these together. So like, for instance, 45 degrees, right? Same idea. We want to go from degrees to radians. So what do? We multiply by, we multiply by pi over 180 degrees to radians. Okay. So by doing so, we get 45 times pi over 180. The degree units actually cancel. So we get this. And if you were to reduce that, well, 180 is 4 times 45, which is pi over 4. For this one, 135 degrees right? What is that? Well, again, we want that in radians. We multiply by pi over 180 degrees. Okay, so what happens? The degree symbols cancel. You get 135 pi over 180. And you can actually reduce that. Namely, you can get this, and you get 3 pi over 4. You know, it's reducing fractions, so lowest terms. Now notice here, I didn't write out radians, but you can see that, but it's understood that this is radians. You know, we didn't write out here pi over 3 radians, so it's understood then that this angle is in radians. Especially since we have pi here. As far as I know, people don't write pi degrees. So, I mean, theoretically you can, but I don't think people do that. Anyway, pi over 3, to convert it to degrees, again, you multiply by 180 degrees over pi. Okay? So, again, what happens here? Well, if you were to multiply it, the pi's cancel. I mean, pi, it does denote a number. So you get 180 degrees over 3, which is 60 degrees. So that's good. Here, we have 5 pi over 6. Okay? 5 pi over 6, right? You multiply that by 180 degrees over pi, because you want to convert it to degrees. Same idea. The pi's cancel. 3, you get 5 times 180 degrees over 3. Okay? I think that turns out to be, well, anyway, it turns out to be 150 degrees. So, wait, that should be a 6. That should be a 6, shouldn't it? I should see that. Is that what you were going to say?
Oh, well, I guess so, yeah, because I was going to say, shouldn't it be 300 if it was 5?
Yeah, my mistake.
Okay. Okay.
My mistake. Just fix it. All right, thank you. So that should be, yeah, 6. I just fixed that. That's good. All right. So here, last one, 2 pi over 5. Okay. Same idea again. You multiply by 180 degrees over pi, right? The pi's cancel. You get 2 times 180 degrees over pi, which turns out to be 72 degrees. So, pretty sure it's correct. All right. All right. Okay, so that's really it for the angles and stuff. I mean, 5.1, they do, I mean, this section, there's a lot more in the book, but this is all I want to do. Now, I want to move on to trig. Are there any questions on this stuff? Okay. So basically here, what's going to happen is this. We're going to have a right triangle, okay? That's what we have here, a right triangle. And again, that's a triangle where one of the angles is 90 degrees, okay? Now, generally, what people do is we denote the 90 degree, the actual angle by this little square. So this angle here is the 90 degree one. Again, a right triangle is a triangle that has where one of the angles is 90 degrees. So that's what, and this is that 90 degree angle. What we're going to do is let theta be one of the other angles. In particular, theta represents an angle between 0 degrees and 90 degrees. Now, for trig, here's what's going to happen. The side that's opposite the 90 degree angle, that's the hypotenuse. Okay, that's the hypotenuse. So I'm going to let that be HYP. The side opposite the angle theta, the opposite side, we denote that by OPP, like this. And the side next to the theta, the side next to it, that's the adjacent side. That's ADJ for adjacent. And usually we put theta down here. Theoretically, you could put theta up here, and then the triangle would look like this. Hypotenuse is still going to be the same because that's opposite the 90 degree angle. This side would be OPP, the opposite side opposite the theta. This side would be the ADJ. This is adjacent to theta. So these two sides are labeled based on their position to the angle theta, opposite or adjacent. This one here, this is the side opposite the 90-degree angle. That's what happens here. Now, we can define the trig functions using the sides here. And when I mean sides here, what I mean is really the lengths of the sides, okay? So maybe I should have said is that, well, no, that's fine what I said. But for instance, if you do sine of theta, which is this, by definition, that's the length of the opposite side divided by the length of the hypotenuse. So it's the length of the opposite side divided by the length of the hypotenuse. I think did I misspoke here? I might have. Yeah, I misspoke. I'm sorry about that. Hype is actually, I mean, this side is the hypotenuse, but one second. Hype is actually the length of the hypotenuse. Okay? Hype is the length of the hypotenuse. This side here is the length of the opposite side. ADJ is the length of the adjacent side. So these are actually the side lengths. So OPP is the length of the opposite side. ADJ is the length of the adjacent side. Hype is the length of the hypotenuse, the length of the side opposite the 90-degree angle. So I think I spoke incorrectly before, so sorry about that. Did someone have a question? Guess not. Okay. Let me just do this.